Space is vast and mysterious. It holds many secrets. NASA sent a spacecraft to uncover these secrets. This spacecraft is called the Advanced Composition Explorer, or ACE for short. ACE is like a space detective. It collects clues about the universe. These clues are particles from the Sun and other stars. ACE helps us understand our place in space. It tells us about the stuff that makes up the universe. ACE is a remarkable mission. It has been working for over 2 decades. Its journey continues to this day. ACE's mission is to study space. It has several important goals. First, ACE wants to know what space is made of. It studies the particles that fly through space. Second, ACE wants to know where these particles come from. Do they come from the Sun or from other stars? Third, ACE wants to know how these particles travel through space. Do they travel in straight lines, or do they curve and bend? ACE is helping us answer these big questions. It is giving us a better understanding of the universe we live in. ACE is in a very special location. It is about 1.5 million kilometers from Earth. This location is called the L1 Lagrange point. The L1 Lagrange point is a stable point in space. It is where the gravity of the Earth and the Sun balance out. This balance is important. It means that ACE can stay in the same place for a long time. It doesn't need to use a lot of fuel to stay in orbit. ACE's location gives it a front-row seat to study the Sun and space weather. It is a perfect spot for a space detective. ACE was designed for a 2-year mission, but it has far exceeded expectations. ACE has been working for over 20 years. ACE's long life is a testament to its design. It is a well-built spacecraft. It has withstood the harsh conditions of space. ACE's long life is also due to the hard work of the scientists and engineers who operate it. They have kept ACE running smoothly for decades. ACE's extended mission has allowed it to make groundbreaking discoveries. It continues to provide valuable data to this day. Section 5. Solar Wind ACE's Insights into the Sun's Breath. The Sun constantly releases a stream of charged particles, a phenomenon that has fascinated scientists for decades. These particles, primarily electrons and protons, are ejected from the Sun's outer layer, known as the corona. This continuous outflow of solar material is what we call the solar wind. The solar wind travels through space at incredible speeds, reaching up to 800 kilometers per second. It carries with it the Sun's magnetic field, creating a complex and dynamic environment in the space surrounding our planet. The Advanced Composition Explorer, or ACE, is a satellite that has been studying the solar wind in detail since its launch in 1997. Positioned between the Earth and the Sun, ACE provides us with crucial data about the solar wind's properties. ACE measures the speed, density, and temperature of the solar wind. These measurements are essential for understanding the behavior of the solar wind and its interactions with the Earth's magnetosphere. In addition to these parameters, ACE also measures the magnetic field carried by the solar wind. This information helps scientists to understand the structure and dynamics of the solar wind, as well as its impact on space weather. The data collected by ACE is invaluable for understanding how the solar wind affects Earth. For instance, when the solar wind interacts with the Earth's magnetic field, it can create beautiful auroras, also known as the northern and southern lights. However, the solar wind can also have more disruptive effects. It can interfere with satellite communications, cause fluctuations in power grids, and even pose risks to astronauts in space. Understanding these impacts is crucial for mitigating the potential hazards of space weather. By continuously monitoring the solar wind, ACE helps us predict and prepare for space weather events. This predictive capability is essential for protecting our technological infrastructure and ensuring the safety of astronauts on missions. The insights provided by ACE are vital for safeguarding our technology and astronauts in space. As we continue to explore and utilize space, understanding the solar wind and its effects will remain a key priority for scientists and engineers alike. Section 6. Cosmic Rays. Unraveling the Mysteries of Space Particles. Cosmic rays are one of the most fascinating phenomena in the universe. These high-energy particles travel through space at nearly the speed of light, carrying with them secrets from the farthest reaches of the cosmos. But where do they come from, and what can they tell us about the universe we live in? Cosmic rays are high-energy particles that travel through space at close to the speed of light. They are incredibly energetic and can penetrate through almost anything, making them a subject of great interest for scientists. These particles are not just from our own sun, but also from other stars and even distant galaxies. The study of cosmic rays can reveal a lot about the processes happening in these celestial bodies. They come from the sun, other stars, and even other galaxies. When stars explode in supernovae, they can accelerate particles to incredibly high energies, sending them hurtling through space. Similarly, the sun emits cosmic rays during solar flares and other energetic events. These particles travel vast distances, crossing the interstellar medium and sometimes even entering our own solar system. ACE, or the Advanced Composition Explorer, studies the composition of cosmic rays. This spacecraft is equipped with instruments designed to capture and analyze these high-energy particles. By studying the composition of cosmic rays, scientists can gain insights into the materials that make up stars and galaxies, as well as the processes that occur within them. It tells us what these particles are made of. Understanding the composition of cosmic rays can help us learn more about the elements that are present in the universe. This information is crucial for piecing together the history of the cosmos and understanding how it has evolved over billions of years. This information helps us understand the origin of cosmic rays. By knowing what these particles are made of, scientists can trace them back to their sources, whether they be supernovae, the sun, or other cosmic events. This helps us build a more complete picture of the universe and the forces that shape it. It also helps us understand the processes that accelerate these particles to such high energies. The mechanisms behind particle acceleration are complex and not yet fully understood. By studying cosmic rays, scientists can learn more about these processes and how they occur in different environments across the universe. ACE's observations of cosmic rays provide insights into some of the most extreme environments in the universe. These particles often originate from regions with intense magnetic fields and extreme temperatures, such as the remnants of supernova or the vicinity of black holes. By studying these environments, we can learn more about the conditions that exist in the most extreme parts of the cosmos. They help us unlock the secrets of the cosmos. The study of cosmic rays is like a cosmic detective story, where each particle is a clue that can help us understand the universe better. Through the work of missions like ACE, we are gradually piecing together the puzzle of the cosmos, revealing its mysteries one particle at a time. Section 7. The Sun's Crown. ACE's study of the solar corona. The solar corona is the outermost layer of the Sun's atmosphere. It extends millions of kilometers into space and is visible during a total solar eclipse as a white halo around the Sun. Despite being the outermost layer, it is much hotter than the Sun's surface, reaching temperatures of up to several million degrees Celsius. This extreme heat is a mystery that scientists are still trying to understand. The surface of the Sun, known as the photosphere, is about 5,500 degrees Celsius, but the corona is hundreds of times hotter. This phenomenon, known as the coronal heating problem, has puzzled researchers for decades. Scientists use various methods to study the solar corona, including ground-based telescopes, space missions, and computer simulations. They analyze data to understand the mechanisms that heat the corona and drive the solar wind, a stream of charged particles that flows outward from the Sun. The Advanced Composition Explorer, or ACE, is one such mission dedicated to studying the particles that escape from the solar corona. By observing these particles, ACE provides valuable insights into the temperature, composition, and dynamics of the corona. These particles, known as the solar wind, carry information about the corona's temperature and composition. They help scientists piece together the puzzle of how the corona is heated and how it interacts with the rest of the solar system. ACE's observations are crucial for understanding the heating mechanisms of the solar corona. By studying the variations in the solar wind, scientists can infer the processes that transfer energy from the Sun's interior to its outermost layer. Additionally, ACE helps us understand how the corona ejects material into space, creating the solar wind. This solar wind influences space weather, which can affect satellite operations, communications, and even power grids on Earth. ACE's study of the solar corona is crucial for understanding the sun's behavior and its impact on Earth. By unraveling the mysteries of the corona, we can better predict solar activity and protect our technological infrastructure from its effects. Section 8. ACE's Toolbox Instruments and Data Collection. ACE carries a suite of sophisticated instruments to study space. These instruments act like ACE's senses. They allow it to see, smell, and touch the universe around it. ACE's instruments include spectrometers, detectors, and a magnetometer. Each instrument plays a specific role in collecting data. ACE sends the data it collects back to Earth. Scientists then analyze this data to learn about space. ACE's instruments and data collection methods have revolutionized our understanding of the sun and the space environment. Section 9. ACE's Legacy. A legacy of discovery and innovation. ACE has been an incredible mission. It has made countless discoveries that have changed our view of space. ACE's legacy extends beyond its scientific contributions. It has also paved the way for future space missions. ACE has shown us the importance of studying the sun and its impact on Earth. It has also shown us the value of long-duration space missions. ACE's legacy will continue to inspire generations of scientists and engineers for years to come. It is a testament to the power of human curiosity and ingenuity.